Hey y'all, I'm here at the site of our Strawbale ADU project, which is a backyard apartment project of 700 square feet. We've taken to calling this project the Bower, after the bower birds that make elaborate nests out of straw and other natural materials. So this is the Bower project. It's a Strawbale ADU, and currently we're just getting the foundation in the ground. So I'm going to show you about that and talk about why our foundation is different, the choices we made, why we decided to use less concrete and more of an earthen floor in the middle of the slab, and how we're going to accomplish that, and some of the obstacles that we faced so far to get to this point, including weather. So come with me and we'll go look at the foundation. So we decided to use a grade beam type of foundation for this project. The reason why is because we wanted to use less concrete. Concrete, the production and the transportation and the use of concrete makes up for 8% of total global emissions. And so we want to try and reduce our amount of concrete in every project that we use. Concrete's definitely usable and it has its place, but it doesn't need to be used in quite so broad of a usage as we tend to use it in the construction industry. For instance, in this project, we didn't necessarily want it to be the floor when we can use other methods for a comfortable and warm floor. So here what we've used it as the grade beam, which is this perimeter that goes all the way around the foundation. It follows the perimeter of the house. It makes up the support for the exterior walls, where the weight of the roof will rest on those walls, which will then rest on this grade beam foundation. It's designed by an engineer. It is, in our case, 18 inches wide because we're using straw bale insulation. Our straw bales are going to be 18 inches wide, so our walls are 18 inches thick. So we made our grade beam 18 inches wide, and in our case it's 20 inches deep. From bottom to top. And I'm in climate zone 4 here. We don't have a very deep frost depth for our projects. So this one is just going to be, it's 20 inches tall. It's going to have 8 inches of exposure from the final grade of the earth to the top of the floor. So we just have 12 inches of the foundation, or of this grade beam, that is down below the level of the grade of the ground around it. We're going to use insulation on the outside of our perimeter to insulate our foundation. This will help keep the floor warmer in the winter, cooler in the summer, for that bit of concrete that is exposed and up above the ground. But the insulation will actually go the entire distance of the foundation, and actually an extra 4 inches beyond that, as required by the insulation code for this area. So we have a perimeter grade beam, and that is 18 inches all the way around, like I mentioned, except on the north wall here. What we did for the north wall, we're actually going to make it into a double stud wall instead of using straw bale along this wall. That's because the code for straw bale does not allow you to put plumbing in any of the straw bale walls. And so just for ease of use, we decided to make the entire north wall of the project an 8-inch wide double stud wall that will have all of our plumbing. We'll hang our cabinets on it. You can hang cabinets on a straw bale wall, but we're just going to make our north wall our utility wall, just to make it easier. And so I will show that as we get farther along and we actually have the walls built. I'll show you what a double stud wall is, and I'll show you how we framed up our walls for the straw bale walls. But for now, we just notched the concrete of the north wall to receive the 8-inch wall. And we do have a little bit of concrete slab in this foundation. We are going to make a concrete slab under the bathroom area. So you can see all this plumbing here behind me. That's going to be the bathroom area of the house. And we wanted to use concrete there, again, for simplicity, for ease. This is the first straw bale structure here in Greensboro, and so I wanted to not raise too many questions at once with the building office, so I decided to do concrete in the area that's a wet room, where there's going to be a shower and a toilet. And we'll probably do a radiant floor heating on top of the concrete there, and then do tile over the top of it. But for the rest of the structure, we will have an earthen floor. So as you can see in the middle of the foundation, all of this right now is open and currently very wet. So we should be done by now with our foundation, but for the month and a half of drought that we had here in North Carolina, as soon as we started working on our project, it started raining every single day. So there was 3 days about a week and a half ago when we were able to get the foundation formed and the concrete poured, and the plumbers were able to start their work, and then it started raining. So we've since had a lot of water build up, and that has sort of brought our project to a halt right now. There's really not much you can do in the rain at this point. The inspectors need to see trenches without water in them. The plumbers need the pipes dry to do their work. So we're kind of stopped by the rain at the moment. The plumbers got started, but they need to come back because their plumbing is too close to the top of the finished floor. I noticed it, and the inspector noticed it too, and so it needs to be adjusted. That is going to be a 4-inch concrete slab right there in the bathroom, and so there's like a ½ an inch between the pipe and what would be the top of the floor now. So he needs to drop that, and he can't do that with all the rain and mud and stuff. So he needs to come back and do that. One of the really important things to do if you are sort of project managing your own build is to double check the location of all your pipes that your plumbers, that your electricians have put in the ground before you get it covered up with a concrete slab or anything, because fixing that stuff later is really difficult to do. And so you want to double come in behind them and double check and make sure that their measurements are right. So I've been doing that as well as we get our underground stuff in place here. It's really important to spend time in the planning phase, thinking about all the details that you might possibly need before you start work actually out in the field. For instance, with the foundation, I've done this type of foundation and I've done earthen floors before, so I knew that it was important to have these recesses next to both of the exterior doors of the project. So we have this bigger one by the back door, which is going to be a 5-foot wide double door, a sliding door, and the smaller one by the front door, which is a 3-foot wide standard size door. And the purpose of this, so that you don't walk in and open the door and you're over a concrete band when the rest of the floor is earthen floor. So we dropped it down 2 inches right here up to the place where the door will sit, and that way the earthen floor can layer over the concrete right here. And we might set tiles or something in that area make it a more durable area when you walk in, if you're walking in with muddy boots or something. That's still an option, but for now we just dropped it 2 inches, the concrete right there. We had the concrete guys form it out so that would drop, and that way we can run the earthen floor over that area. So our next steps when the concrete guys do come back after they take off their forms and clean up their mess, they are going to level out the inside of the foundation with the dirt that you have here. This is actually the native soil. They just scraped off the top, they scraped off the grass and the soil, the topsoil, and pushed it over to the side. And they will come back in and they will level this out that's inside the foundation here. And then we're going to install a plastic vapor barrier. This is a heavy-duty plastic vapor barrier specifically made for this purpose. It's a 10 mil vapor barrier, which refers to the thickness of the plastic, which is pretty thick. It's going to lay across the entire foundation. We're going to tape the seams. We're going to run it up the sides of the walls as well, the sides of the walls of the concrete grade beam, and tape it to the top of the grade beam walls as well. And the reason for that is the whole thing is a vapor barrier, so we don't want any ground moisture from underneath the house evaporating up and getting into our finished earthen floor. And so by wrapping it up the sides of the foundation beam and taping it to that as well, we're also stopping any moisture coming out from outside of the foundation and seeping in through the sides of the walls and damaging our floor. So we will install a vapor barrier. We're going to bring in gravel. This is all engineered to code. It's pretty standard for any sort of, if we were going to do a slab, this is sort of the standard method. We're going to bring in 4 inches of gravel. On top of that, we're going to bring in a fill of sand rock with a specific amount of clay in it. This is the sort of base of the earthen floor, and I'm going to get my concrete subcontractor to bring that in and spread it with his machine and compact it for us. He's going to do that in 1 or 2 inch lifts at a time, I think for a total of 4 inches, and he's going to lightly moisten those layers as he compacts them so that they get really nice and compacted there, and then his work will be done. He'll leave that for us. It should be about 4 inches below the top of the floor, and then we will come in after the framing is up and everything, and we will pour our first adobe lift on the floor. And so I'll get into more details on what that's going to look like then. But for now, we are sort of in the holding stages for weather. We've got to get the plumbers back in here to finish their job, and then the concrete guys need to come back and finish their work, and then we can move forward and hopefully start framing soon. Thanks everybody, stay tuned.